change do we know? It tells us one of the rates of change. Which rate of change do we know on this one? D what do we know? It slips down, it moves away from the base of the wall at 2 feet per second. So d what? What one do we know? We know that one. That's the one we know. We know dx dt is 2 feet per second. Which one do we want? We want dy dt. So if we know dx dt and we want dy dt, what two variables do we want to relate together? We want to relate x and y. We want a function that relates x and y. Do we have one that relates those two? Yes, the Pythagorean theorem tells us the relationship between the two. We know that x squared plus y squared is z squared. That's right here. X squared plus y squared is z squared. So those are the first three steps. Do you understand what's going on? You write down what you know and what you want, and then you write the equation. All of this right here is just implicit differentiation in algebra. So you do the implicit differentiation. You're differentiating with respect to what? Differentiate with respect to what? With respect to what? What's the denominator? To t, the time. So all of those you're treating. We're pretty much home free because you're going to do this derivative. You see this right here? You're going to do this 100 times in this class. What can you cancel on each of them? The 2's. And then after you get to here, which is the one we want? We already highlighted which one do we want. It asked us for one in particular. Which one? We want dy dt. So if we want dy dt, what do we have to do with all the other values? We have to plug in all of the other values. The question told us that it's when x is 4, when y is 3. Hey, if x and y are 3 and 4, what does the z value have to be? If the base is 4 and the height is 3, what does the hypotenuse have to be? 5. Because 3 squared plus 4 squared is 5 squared. This is the ladder. This is the rate of change of the length of the ladder right there. This is the rate of change of the length of the ladder. Is the ladder changing in length? No. So what is dz dt going to be equal to? 0. Oh, does it tell us dx dt? In the question, it told us the base, how fast the base is growing. It told us it. What is it? 2. So you see all these values, 4, 2, 3, 5, and 0. They gave us all those. What's the one value there that we had to figure out? We had to figure out the 5. 3 squared plus 4 squared is?
What's that, a 5-foot ladder?
It also says it's a 5-foot ladder. Yes, that's correct. Actually, so it was y that we needed to figure out the 3. We needed to figure out the 3. I'm sorry, you're absolutely right. Hey, do we have all the values there now? Now it's just algebra, and you solve this, and what do you get? dy dt is negative 8/3 feet per second. Should it be negative?
Yeah.
Why? Why should it be negative? Because it's what?
Going down.
It's going down, yes. Do a reality check on your answer. Do you see how there's no units until the end? That's fine, but what do you have to put in at the end? Units. Please put in the units. So just to dr dt, that is what we know. What's what we want? We want dA dt. We want the rate of change, Nick, of the area. So what two variables do we want to link together? If that's what we know and what do we want to link together? Area. R and area, right. Radius and area. Do you have an equation that links together the radius and the area of a circle?
Yes.
Yeah, it's right here. There it is. And I don't know why. Oh, there it is. What do you do now? You take the derivative in terms of what? The derivative in terms of t. So what does a turn into? dA dt. What do you drop to the front? 2 pi r, but then you have to multiply by dr dt because of the chain rule. Which one do we want in here? Which is the one we want? We already figured out which one we want. We want what? We want dA dt. So we want dA dt right here. So we need to find values for everything else. Did it tell us dr dt? Yeah. It told us dr dt. It's right there. So what's the only thing we need to find now? What's in red right here? The radius, right? How do we find the radius? Well, look what it says. How rapidly is the area enclosed by the ripple expanding at the end of 10 seconds? At the end of 10 seconds. At the end of 10 seconds. How fast is the radius increasing? It tells us the radius increasing at what? 3 feet per second. The radius is increasing at 3 feet per second. So in 10 seconds, how big is the radius? So where do we plug that 30 feet in? Right there. So look what we get. Here it is. And so you can write it as feet per second. And this one was 21/4 feet squared per second. Does that make sense? You feel good about these? Okay. So what I'd like you to do the board.